Hey gang, so let's look at quadratic transformations. So I've got this slide here, and I don't know if you remember it, but f of x equals a times f of x plus c. It's kind of a different, weird notation that we don't use a lot. So before we jump into this notation, I want to go back and I just want to review a little bit. So I want to start off with, let's remember that one of the transformation is a reflection. Now, remember, reflection is when you go across the x-axis, we reflect. And if you remember, in order to do that, all we needed to do was go from the parent function and transform it into something that had what? Do you remember what it had to have in the front to reflect? Hopefully you said a negative. So it had to have that negative. So when we do a reflection, that's when we change this value in the front. All we do is make it a negative. We just flip it, okay? And that flips it over. That made it go from this right here to flipping it over the x-axis like that. Okay, the other one was what we'll call a vertical shift. We'll call that vertical translation or shift. I'll put translation. We tend to like to use that word a little more. That just means, I'm going to draw a little graph here. That means that maybe my parent function was right here like this, and a vertical translation happened, and it moved it up this way, or it could move it down here. Now, in order, I know that's not a great picture, but anyway, in order to get that, we had to do, and I'm going to start right here with my parent function. I'm going to transform that into something like this, x squared. I could say plus 5. This is a vertical shift up. If I did f of x equals x squared minus 5, that would be a vertical shift down. Vertical meaning straight up and down, okay? I'm shifting around. I'm translating. Translate just means to move. Okay, so that was a vertical. Now, the other option we had was a horizontal shift or translation. Okay, horizontal meaning left and right. So on this, let me draw kind of a picture. I might have my parent function. Here it is. If I'm going to shift it horizontally, I might shift it over here. That would be a horizontal shift to the right. I could do a horizontal shift over here to the left, and this would be a left shift. Now, if you remember, if I'm moving along the x-axis, I'm moving with the x. So this was where we said x maybe minus 3 squared. This would be, which way is that going? Okay, remember, and I'm going to put it down here at the bottom. X always does what? X always lies. He never tells the truth. So this says it's moving negative 3, which means it's really moving to the right, positive 3. Now on the flip side of that, we can do another one. F of x equals, let's do x plus 3. Actually, let's do 4 just so we have different numbers there. Okay, squared. This says that it's a positive. So I know it's moving the other direction. It's moving negative 4. So it's moving to the left. So x is live. So we've got reflections, translations, left and right and up and down. Then the last thing we had, and I'm going to draw another line in here so that we can get it all in here in one fell swoop. We had compressions or shrinking and stretching. So let's do a vertical stretch first. And the opposite of that is going to be a vertical shrink or compress. And I'm going to put that word down here, compress, because you will see that sometimes too. Okay, so we can stretch it vertically. And what we mean by that is, let me draw my parent function. So if I've got my parent function, not the greatest, but there it is. If I want to do a vertical stretch, that's where I take these two and I stretch them in so much closer together. Now, the other option of that is if I do Here, oh, let me draw that one more time. Here's my parent function. If I do a vertical compress, I shrink down lower and I get wider. That was the word I wanted. This one is more narrow. I was sitting there thinking, what's the word I'm looking for? Narrow. When you shrink, you get wider. It's kind of the opposite of what you think it might be. Stretching, your graph goes from something like this to something more narrow. This is not very straight, but that one is stretched more narrow. When you do the compression, you're pushing it down, pushing the graph all the way down to the x-axis, okay? That's why it gets so much wider right here. You're pushing it down. Now, how do I get there? Well, remember when I do a stretch, I'm getting more narrow. So I want the number in the front of x squared to be big. If I'm going to shrink, I want the number to be smaller. I want it to be a fraction. Now, not just a fraction. It has to be, I'm trying to see where I have room to write this. I'm running out of room. I have to have, in order to do this one, my fraction has to be between 0 and 1. Okay? So, if I had a fraction like, I don't have anywhere to write it, but if I had a fraction like 9/2, that is bigger than 1, so therefore that is not going to work. This is a fraction, yes, but it's not between 0 and 1. It has to be a fraction between 0 and 1. When it is, that's when I'm shrinking and getting wider. Okay, so that's my basics. You're going to want to go back and refer to this often as we're doing these next things, because what I'm going to do is I'm going to be rotating and reflecting and everything, but I'm not going to use numbers. I'm only going to use variables. It's not as bad as you think. All right, here we go. Okay, so here's what I've got. F of x equals a times f of x. So in this scenario, I want to know, what does this do? What does the a do? Okay, I'm going to underline a. Do you remember what a does? A, and let's go back and look. The a, this number in the front, it either reflects it like it did right here. I'll circle it right here. That reflected it, right? But it also did what down here, down at the bottom? What did the a do down here? Yeah, didn't it vertically stretch and shrink and compress it? Okay, so let me undo those. Let's go back over. So this a is going to shrink our graph. It's going to stretch our graph. And it had one more thing. If it's negative, it's going to reflect our graph. Shrink, stretch, and reflect. That's what A is going to do. Now, let me change colors. And let's look at C. What does the C do? What happened when I added something on the end? Right here, I had a vertical translation. Okay, so C is going to move the graph up or down. Okay, it's going to do one of those two things. That's all it's going to do. C, moving up or down. All right, now we got our last one. Oh boy. So this one, when you have parentheses, so this one you're going to move with the X. So what does that do? When you move with the X, you're moving horizontally or side to side. Horizontally, side to side. Okay, so we're going to need to remember those. Those are our basics. We're shrinking, stretching, and reflecting when we're up here. We are moving up and down when we're moving with the C. And when we're in parentheses and we're moving with the X, we're moving side to side. Those are our basics. All right, moving on. So here we go. So what I want to do is I want to look at these and I want to say, okay, what's happening? F of x equals 3f of x. So we're assuming that f of x is a quadratic function. when I put a number in the front of it, what does that 3 do? Well, remember, if we go back over here, when I'm talking about the A, I'm shrinking, stretching, or reflecting. Or maybe I'm doing a couple of them. If I have a 3, 0 is less than x is less than 1. That's the way I shrink. Shrinking has to be a fraction. Fractions make your head hurt. It makes you want to put your head down to the ground and shrink down to the x-axis. That's a 3. That's bigger. So that means, hopefully you already wrote it, that means I'm stretching. So I should have put vertical. This is a vertical stretch. It's getting more narrow. And the downside of these is you can't put these into your calculator. That's why I want to be sure you understand this language. Okay, take a second, look at the next one. Okay, I see a negative and a 2. There's 2 things here, negative and a 2. The negative reflects it. And what does the 2 do? Just like before, it does a vertical stretch. And gets more narrow. Okay, take a look at that last one. I don't see a negative, so I'm not reflecting, but I do see 1/2. And I'm going to look up here and say, oh, if it's between 0 and 1, this would be a vertical shrink. It's getting wider. I know it's like, what? That seems so backwards. But my graph is going from the parent function, and it's getting wider. It's pushing down, it's shrinking down to the x-axis down here. All right, guys, well, I'm going to stop right there because I hear people coming in. I will finish this later. Oh, actually, that is just my other family. Yes, I'm going to finish this later.